Yes, let me start today's session. Yesterday afternoon, there was some technical glitch. I could not take class due to that problem. It could not telecast actually. Okay, so let me continue today's class. Yesterday we completed filtration. So now let us start new topic. What is that new topic? Disinfection. Okay, the filtration remove most of the dissolved organic substances along with a few microorganisms, but not all microorganisms. Okay, still so many microorganisms remain in water. To remove those microorganisms from water, we apply disinfection. So actually, disinfection is aimed to destroy disease-causing microorganisms known as pathogens present in water. So until unless disinfection is completed, treatment is incomplete. So disinfection is very important in water treatment, especially drinking water treatment. Okay. So disinfection, it is a method of destroying disease causing organisms. Organisms known as pathogens. To render water safe to drink is known as disinfection. Okay, so disinfection not only destroy the existing germs present in water but also protect water against future contamination. So disinfection not only destroy existing germs means microorganisms only, and also protect water against future contamination at the time of supply. See now, when you are preparing for exam, in the class you are very comfortable. When you are comfortable only in the class, it is of no use. You are supposed to be comfortable in the exam. So to get that comfort level in exam, so you have to revise the content and you have to prepare repeatedly. Then only you will become comfortable and reproduce properly in exam. So there is no guarantee that if you just prepare for the exam, there is no guarantee that you can remember everything and reproduce in the exam. So for that it requires practice. So that will give you success. That's why revision classes they are conducting, isn't it? This revision batch is only for that purpose, to retrospect whatever you have learned once again, to brush up all those concepts fast, so that that will give us good success. Exactly same way, at the time of treating water is absolutely safe, no doubt at all. At treatment plant, water is completely safe. Then what is guarantee that water remains safe till it reaches to consumer? Water is supplied to consumer by using what? Distribution system, that is network of pipelines we use. So there is every chance that water may recontaminate while carrying water in a pipeline. So pipelines are not foolproof, isn't it? So because of faulty joints, because of leakages, so exfiltration, infiltration is a common problem. So something inside the pipe get out of the pipe, something outside pipe get inside the pipe. So when microorganisms present in the ground get into pipelines, again water may get recontaminated, isn't it? Chance is there for recontamination. So therefore, even microorganisms try to get into water supplies, there is something in water that will not allow those organisms to resurface in water when you carry out disinfection. That is how water is protected against future contamination. Understood? So till the last drop of water we deliver to the last consumer, water should be protected. Isn't it? That is the object of our course. Till we deliver the last drop of water to the last consumer, water completely protected, so that we can protect public health. Isn't it? Last consumer, if water reaches safe, then every consumer living in a community, automatically water reaches safe to them. The final farthest consumer gets water, wholesome water, then everybody living in a community also get wholesome water. There is no chance of any recontamination. To achieve that, so water must be disinfected. Just you supply without disinfection, chance is there for recontamination. So to protect that, to overcome the risk of recontamination, water must be disinfected. Okay? So disinfection is compulsory. Disinfection is mandatory. Okay? The substances used to carry out disinfection are known as disinfectants. Substances used to carry out disinfection are known as disinfectants. Understood? See, now in Corona time, this is a Corona time, and everybody asked to clean their hands with soap. Everybody asked to clean their hands with what do you call sanitizer. What is that sanitizer? Nothing but a disinfectant only, which disinfect your hands. What is a soap? Which disinfect your body, isn't it? So disinfection is there everywhere, not only in water, everywhere it is there. So any microorganism that is there in your hands, to see that that will not get into your body. So if you sanitize your hands regularly, frequently, so those organisms are killed. So your health is protected. Sanitization prevent the spread of COVID, isn't it? Sanitization, cleanliness, right? That is very, very important. So exactly how we disinfect ourselves by bathing with the soap, how we sanitize our hands with the sanitizer, how we wash our cloth with the detergent. All these are disinfectants only. They also destroy organisms present at different surfaces. Okay? Organisms flourish everywhere. Microorganisms you notice everywhere. So to see that we are completely protected against those organisms, we should disinfect ourselves, we should disinfect our cloth, we should disinfect our floor, our house, we should disinfect our bathrooms, we disinfect our water closet once in a while. So we should carry out this job, isn't it? So similarly, the water also must be disinfected. So the phenyl which we use for floor, detergent we use for cloth, soap we use for body, right? Sanitizer we use for hands. Similarly, there are some special kind of substances that are used as a disinfectants to disinfect water. So we have to talk about them. So what is that thing that we can use to carry out disinfection? Okay? They are called disinfectants. So there are so many ways we can disinfect water. So let me write those methods. Methods of disinfection. The first method is by using So these methods are broadly classified into two categories: physical methods and chemical methods. Physically also we can disinfect water, chemically also we can disinfect water. So let us see about physical methods of disinfection. Physical methods, first one. In physical methods, we have got two ways we can disinfect water. One is by using heat energy, by using light energy. By heat energy. Heat energy means what? Boiling water. By using light energy. What is that light energy we use to destroy organisms? Ultraviolet UV ray treatment. By using UV rays, ultraviolet rays, we can disinfect water. Okay. Similarly, we also have got so many number of chemical methods. Second is chemical methods. Most of the chemicals are chemicals which have got oxidizing power. They can be used as disinfectants. So many are there. So one is by excess lime treatment. Excess lime treatment, we can disinfect water. 2, right? Treatment with metal ions. You can disinfect water. Then 3, treatment with the potassium permanganate. A chemical it is. And 4th is treatment with ozone. And 5th is treatment with the halogen group of chemical substances. Such as iodine, bromine and chlorine. So among all these, in bulk water treatment in India, most of the times we disinfect water with chlorine only. So we talk about only chlorine, disinfecting water with chlorine. So before that also, there are so many number of methods are there. So I'll discuss one by one. So when you disinfect water, so the thing is, it not only destroy the present germs in water, but also take care of future possible contamination. Boiling water, you see, boiling is nothing but rising the temperature of water. When you rise the temperature of water, right, microorganisms best grow at 37 degrees Celsius. If you increase the temperature, their growth decreases. So when you increase the temperature above 60 degrees Celsius, only few organisms can survive. Above 70 degrees Celsius or 80 degrees Celsius, no organism can survive. So by rising the temperature of water above 80 degrees Celsius and below 100 degrees Celsius. Above 100 degrees Celsius, if you rise the water, what happens? Water also evaporates. Water should not evaporate. At the same time, we should kill the germs. We should destroy the organisms. For that purpose, we try to rise the temperature of water by boiling above 80 degrees Celsius so that we can get 100% destruction of organisms in water. But the problem with boiling is it only destroy organisms only at the time of treatment, but there is no future production. So having that future production is called residual power. So boiling has not got residual power. It doesn't protect water against future contamination. Therefore, boiling is ruled out. In bulk water treatment I am talking. In bulk water treatment, boiling is ruled out. Boiling is only employed just to as a individual practice. Boiling is recommended only for individuals During epidemics, individuals are advised to boil and drink water. Practiced at individual level. So not used in bulk water treatment. Bulk water treatment means large scale water treatment. Municipal corporation, so it is not possible to employ boiling as a means of disinfecting the water. Not used in bulk water treatment. The reason is boiling is expensive, costly process because fuel is required to rise the temperature of water. Expensive method, first one, and second one is no future protection. So because of these two reasons, it is not used in bulk water treatment. Okay, so that's about boiling, but individual levels. So during epidemics, public are advised to boil and drink water. During epidemics, epidemics means what? Already explained. Widespread of diseases in the community. During epidemics, public are advised to boil and drink water. Beyond that, there is no much large scale application of boiling. Okay, so boiling is ruled out in bulk water treatment. So not used in bulk water treatment. So therefore it is not used bulk water treatment, but at individual level you can think. Then second one is UV ray treatment. So the ultraviolet rays. See now, human beings are sensitive to ultraviolet rays. Then forget about organisms. Organisms are too sensitive to ultraviolet rays. So UV rays in the wavelength, especially 250 to 260 nanometers, they have got very high germicidal power. So UV rays in wavelength ranging from 250 to 260 nanometer have got very high destructive powers. So if at all we use UV rays, we have to maintain that wavelength anywhere between 250 to 260 nanometers. Okay. So the amount of destruction that occur in water, some amount of destruction occur in water, that depends on one, intensity of UV rays and the time of exposure, and two, time of exposure of UV radiation. How long UV radiation is exposed to water and with what intensity it is exposed. Time of exposure given by the following equation. So this kind of questions they will ask in GATE exam. Wherever chance is there for numerical, there you need to focus. So the equation is ln Nt by N0 is equal to minus K into I into T. So using this expression you can find out. So in this equation, Nt is equal to number of organisms in water. Organisms remained at a time t, and N0 is equal to initial number of organisms present in water. That is at a time t is equal to 0. At time t is equal to 0, number of organisms in water is N0. So after exposure for time t, the number of organisms remained in water is Nt. So t is known as time of exposure. time of exposure or contact time, or you can say detention time also. And I is known as intensity of UV radiation. Intensity of UV rays. Normally it is expressed in microwatts per centimeter square. Contact time is normally expressed in seconds. Okay, seconds or minutes otherwise. Depends on K unit. K is known as disinfection rate constant. So it is a disinfection rate constant. Normally depending upon the unit of K, so T unit depends. If K is given, suppose it is centimeter square per microwatt second and T is in seconds. If it is given centimeter square per microwatt minute and T is expressed in minutes. So based on that T unit is decided. So this is how we can work out the amount of destruction that occur in water. Okay. So percentage destruction occur in water, how we can calculate? Percentage destruction of organisms is equal to, how we can work out? Initial number destructed by initial number into 100. So this is how we can work out N0 minus NT by N0 into 100. Okay. So let us try one question, one numerical GATE kind of question. Find time of exposure of UV rays of intensity 30 microwatt per centimeter square to reduce organisms from 10 power 6 to 100, 10 power 6 to 100. UV rays required. Come on, work out. I'll give 1 minute time, try to work out this problem. So what is given to you? N0 is given. N0 is given as 10 power 6. NT is given as 100. I is given as 30 microwatts per centimeter square. And K is given as 6 into 10 power minus 3 centimeter square per microwatt second. Then you have been asked to find out what? Time of exposure. So it is ln NT by N0 is equal to minus KIT. So you can substitute in this equation. NT is 100, N0 is 10 power 6 minus 6 into 10 power minus 3 into 30 into T. So straight away you will get answer in seconds because this is expressed in centimeter square per microwatt seconds. This is in microwatts per centimeter square. This is also in seconds, so that you get number. Okay, T unit depends on K unit. So therefore T is equal to, come on, work out. So I am using calculator because GATE exam calculators are allowed. So make use of calculator and find out. So I got 51.16 seconds. So they may ask you a question like this. Okay? Or they may ask a question. Example 2. Anyone could be unknown. Find percentage destruction of organisms in water by exposing water to UV rays of intensity 40 microwatts per centimeter square for 30 seconds. Okay? If 30 seconds. The initial number of organisms in water are initial number of organisms in water are 10 lakhs. Okay? $10 lakhs per 100 ml. Okay? Take K is equal to 6 into 10 power minus 3 centimeter square per second per microwatt. Microwatt second. Okay. Sorry. Okay, come work out. So what you have to find out? First you have to find out. You have to find out NT. N naught is given. It is 10 power 6 or 10 lakhs. Ten lakhs means 10 power 6 number per 100 ml. It's like MPN only. MPN test we express like this. Then what is NT? That you have to find out. NT per 100 ml. If you know NT per 100 ml, automatically you will get this answer. This N naught per 100 ml. This N naught per 100 ml. 10 power 6 per 100 ml. MPN we express like this only, not most probable number. MPN is nothing but number of organisms in a given volume. So for this what he has given, T is given as 30 seconds, I is given as 40 microwatts per centimeter square, K is given as 6 into 10 power minus 3 centimeter square per microwatt second. Come on, what you need to do? So using expression ln NT by N0 is equal to minus KIT. We'll find out NT value. So ln NT by 10 power 6 is equal to minus 6 into 10 power minus 3 into 40 into 30. Therefore NT is equal to so find out so I got 746.58. That means almost 747 number per 100 ml NT. Okay. Therefore, percentage removal is equal to, it is N0 minus NT by N0 into 100. So it is 10 power 6 minus 747 by 10 power 6 into 100. So 10 power 6 minus 747 by 10 power 6 into 100. So we are getting almost 99.92% of destruction. That was the answer for this question. This is how you can work out. Understood? You can also ask percentage removal. Then also you can find out. So next method is excess lime treatment. This excess lime treatment, microorganisms are sensitive to pH. By increasing the pH value above 10.2, right, above 9.5. So by adding excess lime, pH of water is increased above 9.5 to get 100%. 9.5 is known as excess lime treatment. So at pH greater than or equal to 9.5, we will get almost 99.99% of destruction of organisms in water. That's what we try to do. But this is not used in bulk water treatment. This method not used in bulk water treatment. The reason being, what is the reason? Because it produces milky turbidity in water. Bulk water treatment, because lime produce milky opaqueness in water. What is opaqueness? Turbidity. So that's why ruled out it is. So water appear like a white milky turbidity appear in water. So consumer reject it. So consumer acceptance is the first priority. Therefore, it is not being used in bulk water treatment. But still, this is one of the methods available to disinfect water. Next method is treatment with metal ions. Treatment with metal ions. So silver and copper have got very high. Silver and copper have got. That's the reason why we use copper vessels. Elders are advised to you to drink water from copper glass, copper tumbler, copper mug. They use no. The reason being, if you store water in a copper or silver vessels and if you keep it overnight, then all of the germs present in that water is destroyed by silver and copper. Okay. Silver is more disinfecting power compared to copper, but silver is very expensive. Therefore, this method also not been recommended for bulk water treatment. Silver and copper have got very high, have got germicidal powers. Germicidal powers means germ destructing powers. germicidal powers. Silver is more powerful than copper. But silver is very expensive, therefore not used in bulk water treatment. I was talking about only bulk water treatment here. Therefore, not used in bulk water treatment, but is one of the methods available. If you have money, you can go with it. Next method is treatment with potassium permanganate. KMNO4, potassium permanganate. Okay? Potassium permanganate is a powerful oxidant. Which can oxidize any substance present in reduced state. Oxidize means it destroys any substance present in water in reduced state, including microorganisms. This is the disinfecting water with potassium permanganate is economical, and this are not required. But yet potassium permanganate is so popular. The reason being potassium permanganate takes long time to disinfect water. It takes its own time. But potassium permanganate takes 24 hours to 48 hours time. 24 hours time otherwise. Not 48, 24 hours to 24 hours to 48 hours time. Excuse me. 1 minute. Excuse me, 1 minute. Class lo unnamma. And 4 hours to 48 hours time to destroy organisms. So very slow. Therefore, not used in bulk water treatment. Bulk water treatment we don't use this, but it's very popular in disinfecting water in rural areas, especially the well water in rural areas. So very popular method in rural areas to disinfect well water. Water from open wells, especially to disinfect water from open wells. So open well waters you want to disinfect, the best method is potassium permanganate. Cheap method, economical. So villagers and all, they don't have plenty of money with them, so they can choose this method. Best method also, but takes time. That's the only reason. It takes so long time, so in bulk water treatment, meeting demand very fast is the first priority. Therefore, it is not being used in bulk water treatment. So, time also very, very important for it. Time constraint also there with us. Then, treatment with ozone. All these are not been practiced in India. The reason I am writing these reasons, in bulk water treatment I am talking. Elsewhere they are practiced. Mineral water and all, but bulk water treatment no. So disinfecting water with ozone is known as ozonization. Disinfection of water with ozone is known as ozonization. A very popular method at this point of time in the world. At this point of time in the world, this is very, very popular method. But ozonization is very costly method. It requires power to produce ozone. So very expensive method. very expensive method, require power to generate ozone. And ozone is unstable, which cannot be stored. You can't store ozone and generate it just before use. Okay? So storage property also very important in India. So we manufacture ozone at one place, central place, then we supply this to other parts of the country. But unfortunately, ozone is unstable. Even if we store also, it loses its power. So ozone is unstable molecular of oxygen. Always try to attain stable molecular form. In doing so, it loses its power. So ozone is unstable isotope of oxygen. Always try to attain stable molecular form. Ozone is unstable isotope of oxygen. Always try to attain stable molecular form. In doing so, it loses its power. That's the reason why you can't use. It loses its power. So it becomes powerless. Then what is use? It can't destroy organism. That's why it is also ruled out. Therefore, this method is not used in bulk water treatment in India. Therefore, this method is not used in elsewhere in the world. People are using, but in India, not used. Bulk water treatment in India. Okay, we have justified all these methods. Then last few more methods are there. So we also have got halogen group of chemical substances. So you can also think of using them. And whatever points I am writing, this is not only important for GATE exam, also important for ESE exam. Because ESE exam, more of conceptual questions they will ask. Halogen group of chemical substances. What are the halogen group of chemical substances you are aware of? Iodine, bromine and chlorine. Iodine, bromine, and third one is chlorine. This iodine and bromine not available in bulk quantities. Not available in bulk quantities which are required for bulk water treatment. Therefore not used in bulk water treatment. Bulk quantities are not available. Available in the form of pellets and tablets. In the form of pellets or tablets. Therefore, not used in bulk water treatment. Bulk water treatment require bulk quantities. Unfortunately, bulk quantities of these two are not available. Therefore, what is left with you finally? Only chlorine. So that's why chlorine only, very popular one. Chlorine is widely used in India to disinfect water in bulk water treatment. The reason is, many reasons are there. So one of the reasons is, it is economical to disinfect water with chlorine. Chlorine is a cheap chemical compound. And second reason is, it protects water against future contamination. Chlorine. So widely used in India. In bulk water treatment. So whenever we talk about bulk water treatment of disinfecting the water, it is only chlorine we use. So we need to know more about chlorine. Rest of them just have ideas. little idea is there more than sufficient, because they are not popular in India, especially in bulk water treatment. Therefore, little idea is there more than sufficient, but with respect to chlorine, you are supposed to have more idea. Understood? Or any doubt is there? Am I confusing you? Good morning, all of you. Okay? Let us see about chlorine. So, disinfecting water with chlorine or its compounds is known as chlorination. Disinfection of water with chlorine or its compounds is known as chlorination. So chlorination is the popular method of disinfection in India. So disinfecting water with chlorine is economical. Chlorination is economical, cheapest method. It is one of the cheapest methods. Of course, potassium permanganate also cheap only. Lime also cheap method only. One of the cheapest methods to disinfect water. Cheapest methods of disinfection otherwise. And one more advantage of chlorine is, so chlorine also chlorine has got very high residual power. Residual power means any substance which has got residual power means, what is residual power? So residual power give future protection. Residual power give future protection in water. Future protection to water. So it has got that power. Very high residual power. Till we supply water to the last consumer, water is protected. Okay? That's why very popular method. So residual power means power remained in water. One is cheapest method, second one is residual power. We can't expect anything beyond this. Therefore, it is very popular method. Certain drawbacks also there, but in spite of that, chlorination is very popular method in India because of economic reasons. Okay? When chlorine is added to water, two things happens. When chlorine means Cl2 is added to water, then it produces HOCl, hypochlorous acid. And OCl minus, hypochlorite ion in water. So this HOCl and OCl minus form in water together known as free chlorine or freely available chlorine. Free chlorine or freely available chlorine in water. So whenever you come across with a term called free chlorine, by default it is HOCl and OCl. Freely available chlorine. Okay. So what happens is, first chlorine is added to water, then it hydrolyzes and produces HOCl plus HCl. HOCl further dissociate into OCl minus plus H plus and OCl minus. Okay, this is called ionization. It ionizes into H plus and OCl minus. So this equation is governed by pH. So this HOCl, this OCl minus produced in water together known as free chlorine, hypochlorous acid, hypochlorotoluene. But HOCl is more powerful than OCl. HOCl is more powerful than OCl. Therefore, we wish to have more HOCl in water. So normally when pH of water is less than 7.5, right, there is more HOCl in water than OCl minus. When pH of water is greater than 7.5, there is more OCl minus in water than HOCl. Therefore, we have to maintain pH how much? Less than 7.5. Therefore, HOCl is more than OCl. So, something related to this equation, they are asking questions in GATE exam. Chemistry related numerical questions, because civil engineers are poor at chemistry related numerical questions. So, that's why they are asking this question in the exam, GATE exam. Very popular question in GATE exam related to this. HOCl calculation, OCl calculation, pH relations, etc., etc., etc. Digest this information, okay? Now, how to work out the HOCl and OCl that form in water? So, percentage HOCl that form in water. Before that, we try to establish relation between HOCl and OCl. Relation between HOCl and OCl minus. How to establish? By writing ionization equation. How you can write ionization equation? HOCl, OCl and pH. I am saying now pH. So by writing ionization equation, what is that ionization equation? So HOCl gives rise to H plus and OH minus. If you write ionization equation, product of products by H plus into product of reactants by HOCl is equal to K. This is called ionization equation for this reaction, chemical reaction. Using this reaction, then we can write we can establish relation between OH minus and OCl minus, right? H plus and OCl minus, OCl minus, this is. pH concept is coming in between. So how to relate them? OCl minus by HOCl, you can write it as K by H plus. So that is how there depends. The relation we can establish. So OCl minus is inversely proportional to H plus and HOCl is straight away proportional to H plus and H plus is inversely proportional to pH. Therefore, when pH value is very high, right, what happens? H plus is very low. When H plus is low, OCl is more. When H plus is low, HOCl is less. Understood? So at a high pH, pH is high, there is more OCl, less HOCl, and vice versa. From this equation you can realize that. Understood? Just to give idea, I am writing this. So, OCl minus is straight away proportional to 1 by H plus. HOCl is straight away proportional to H plus. And H plus is inversely proportional to pH. So when pH is very high, H plus is very low. H plus is low, HOCl is less. H plus is less, OCl is more. So therefore at high pH, there is more OCl, less HOCl. Similarly, when pH is low, at low pH, when pH is very low, then H plus is very high. H plus is very high, HOCl is more. H plus is more, OCl is less. So at low pH, there is more HOCl than OCl. That's the relation between, kind of relation that exists between HOCl and OCl. The amount of HOCl and OCl that produce in water, that depends on pH. Understood? So we wish to have more HOCl in water than OCl minus, because HOCl is more powerful than OCl. To get more HOCl in water, what we do? We try to maintain pH. So concentration of HOCl in water, or HOCl concentration in water. How to find out HOCl concentration in water? So HOCl is released in water by adding chlorine. So chlorine is added to water externally, it's called chlorine dose, into percentage HOCl in water. So how to find out percentage HOCl? Percentage HOCl is equal to only two things will form. One is HOCl, second one is OCl. HOCl plus OCl minus into 100. So if you take HOCl to denominator, you can also write it as 1 by OCl minus by HOCl into 100. Since OCl minus by HOCl is equal to, it is K by H plus. We got now here relation K by H plus. I can replace this. Percentage HOCl is equal to, so percentage HOCl is equal to, it is 1 by 1 plus K by H plus into 100. So you will get percentage HOCl like this. So that is how we can maintain more HOCl in water than OCl by adjusting the pH of water. Okay. So 2 equations, 3 equations. Based on this, they keep on asking questions in GATE exam. Clear now? pH is less than 7. Still it is there, but very little amount you can find. Okay, let us see. We will solve some problems. When you solve problems, things will be clear. Because it is less than 5.5, then only you don't find either HOCl nor OCl, because at pH less than 5.5, the chlorine doesn't dissolve in water, it remains as elemental chlorine. But above 5.5 to 7.5, there is more HOCl in water than OCl. Both will form, but more HOCl, less OCl. Above 7.5, there is more OCl than HOCl. Understood? Alok Pandey? Is it clear? Mr. Alok Pandey, is it clear? So let us solve one problem. Numericals is all you can better understand. So let us try this problem. Example 3 today. GATE question this is given in GATE exam. What is K in this equation? Ionization constant. This K is known as ionization constant. This is ionization equation. Understood? So example 3. Find pH of water to have 90% HOCl in water. Take K is equal to 2.7 into 10 power minus 8 moles per liter. Question is very clear. Find pH of water to have 90% HOCl in water. Take K is equal to 2.7 into 10 power minus 8 moles per liter. Come on, all of you work out. So which equation you have to use? This equation. So percentage HOCl is equal to, it is 1 by 1 plus K by H plus into 100. So percentage HOCl is given as 90. Then K value is given as 2.7 into 10 power minus 8. Then find out H plus. If you get H plus, then you can get pH value. I have given into to you. Come on, work out. Try this question and give me answer there. Okay. Simple formula substitution, nothing is there. This question has been asked in GATE 2004. This question is GATE 2004. Of course, so much matter is there. I have removed that matter. Simple question is simple. Options are given, pH values, but I have not given options. You just work out. So percentage HOCl is equal to 1 by 1 plus K by H plus into 100. This is 90. 1 by 1 plus 2.7 into 10 power minus 8 by H plus into 100. So from this find out H plus. Come on, H plus value, work out. So 100 by 90.9 it is. So 1 minus 0.9. 0.1. Inverse 1 by x into 2.7 into 10 power minus 8 into 0.9. I got H plus value. So it is 2.43 into 10 power minus 8 minus 7. I got H plus value this much. Maybe I am wrong, you verify. Therefore pH is equal to log 10 1 by H plus. So log 10 1 by 2.43 into 10 power minus 7. Come on, work out this value. Oh, I'm getting wrong answer. Come on, verify all of you. It is 90 by 100, that's 0.9, 0.9 into 1, 0.9. So 1 minus 0.9, 0.1. So 0.1 is equal to, from this I can write, it is 0.9 is equal to 0.9 plus 0.9 into 2.7 into 10 power minus 8 by h plus is equal to 1. Therefore h plus is equal to h plus I have to find out, right? Come on, help me in working out that value. 1 minus 0.9, 0.1, 0.1 divided by so 0.9 into 2.7 into 10 So I got 6.61. Yeah, this is correct. And now I got correct value. This is right only. That was the answer for that question, 6.61. Yeah, very good. Alok Pandey, thank you. Let us try next one more question. These are all GATE questions only. This is ESE question. Let us try one ESE question also. He has given question. This is ESE question. He has given like this. What is the fraction of course, options are given. H2Cl in water at pH 7. So in this question pH is given. What is H2Cl fraction in water? You have been asked to find out. Come on, try. This is ESE question. Without calculator you can manage this. ESE exam calculator is not allowed, as you all know that. Come on. What to do? So fraction means remove that 100, it become fraction. So H2Cl fraction in water is equal to percentage means 100, multiply with percent 100, it become percentage. If you do not multiply with 100, it become fraction. H2Cl fraction in water is equal to It is 1 by 1 plus K by H plus only. So he has given pH is equal to 7. Therefore H plus ions in water is 10 power minus 7 moles per liter. Okay, and K value given in the question. Therefore HCl fraction is equal to 1 by 1 plus 2.5 into 10 power minus 8 by 10 power minus 7. So 10 power minus 7, 10 power minus 8 cancel out. You left with 1 by 7 cancel, no? This 7 gone, only 1 is left here, 10 power minus 1. 2.5 into 10 power minus 1 is how much? 1 by 1 plus 1 by 1 plus 0.25. So 1 by 1.25, which is equal to 0.8. That means 80%. Percentage means 8, fraction means 0.8. That was the answer for this question. So without calculator, you can easily comfortably work out this one. Okay. Similar lines, they may ask you a question. Questions like this in exam, GATE exam. Okay. Next concept is chlorine demand of water. So as soon as chlorine is added to water, chlorine is not used in destroying organisms. Chlorine first react with iron and manganese present in water. Chlorine then react with ammonia present in water. Then finally react with microorganisms and destroy them. In doing so, it takes time. So after destroying organisms, no more chlorine is used in water. So any excess chlorine present beyond destroying all these things, iron and manganese, ammonia and microorganisms, after destroying all these things, after reacting all these things, any excess chlorine present in water, that appear as a residual chlorine, which give protection to the water. Therefore, chlorine demand of water is nothing but chlorine consumed in oxidizing iron and manganese, in reacting with ammonia and destroying the organisms is known as chlorine demand of water. Okay. So mathematically we have to work out. Some numericals are asking in the exam. So chlorine first oxidizes iron and manganese. Iron means Fe2 plus and manganese is Mn2 plus. Then react with ammonia and finally destroy organisms. In doing so, some amount of chlorine is consumed in water. That amount of chlorine consumed in water in reacting with this substance is known as chlorine demand of water. So chlorine consumed in water is known as chlorine demand. The above substances is known as chlorine demand of water. So after reacting with these substances, if any excess chlorine remain in water, that appear as a residual chlorine. So I need 100 rupees to meet all my day-to-day needs. Some money is required for my breakfast, some money is required for my lunch, some more money is required for my dinner, some more money is required for to buy 1 or 2 cups of tea in a day. After meeting all these demands, any excess money remain with me that I can save in the bank. That will take care of my future requirements, isn't it? Exactly same way, Some amount of chlorine is consumed in reacting with iron and manganese. Some amount of chlorine is consumed in reacting with ammonia. Some amount of chlorine is consumed in reacting with microorganisms. After reacting with these three substances, any excess chlorine remain in water that appear as a residual chlorine. That will give future protection. That's called residual power. If any excess chlorine remain in water, if any after meeting the chlorine demand, is known as residual chlorine. What is that? Residual chlorine. What residual chlorine does? Protect water against future contamination. That's the best part of chlorine. So we wish to have residuals in water to get that future protection. Therefore, we need to adjust chlorine dose in such a way that, so we need to meet the chlorine demand, and we're supposed to have some excess chlorine in water so to get the future protection. We wish to have future protection in water. To get that future protection in water, how much chlorine to be added to water? So that's called chlorine added to water is called chlorine dose. So chlorine dose added to water is equal to, right? It is chlorine demand of water plus residual chlorine. What is that excess chlorine should remain in water? That will give chlorine dose. How much money I need to earn to meet all my expenses and as well as some savings in my account to meet my future expenses. Suppose every day I need to save some 3000 rupees per month. So every day my expenses are some 200 rupees or some 500 rupees. 500 rupees every day I require. At the end of the month, I suppose to have a savings of some 10,000. Every day my expenses are 500. So 500 into 30 days, 500 into 30 days, approximately 15,000. Plus I suppose to have a 10,000 savings. So 15,000 plus 10,000, 25,000. So if I earn 25,000 rupees per month, I can meet my needs. At the same time, I can have a extra savings also in my account. That savings will take care of my future requirement. Exactly same way. This one also. Understood? Alok Pandey. Only Alok Pandey is taking class now. No one is there. So, whenever they ask chlorine demand, how to work out chlorine demand? So, chlorine demand of water is equal to exactly opposite. Chlorine dose minus residual chlorine. Chlorine dose minus residual chlorine will give chlorine demand. Or chlorine dose is equal to chlorine demand plus residual chlorine. For a given demand, we work out dose. For a given dose, we can work out demand as well. Okay? Based on this, they are asking questions in GATE exam. Okay? Let us try one question related to this. Let us try this question. Good question. Example. Oh, this is 3. This is 4. Example 5. For a water, the dosage, chlorine usage, the treatment of 20,000 cubic meter of water per day. We can write like this. Not necessarily. Eight kilograms. The residual after 10 minutes contact is 0.15 milligram per liter. Find chlorine demand and chlorine dosage, chlorine dose and chlorine demand of water. Come on, work out. Good question this is. Try. So how to work out? Tricky question, no? So you can find out like this. Total chlorine consumed, used or consumed per day. Eight kilograms. How to find out total chlorine consumed? Total chemical substance in any water is equal to Q into chlorine dose. You can write like this. Therefore, Q into, this is given as how much it is? 8 kilograms per day. I'll write here. So total chlorine consumed is equal to Q into chlorine dose, which is equal to 8 kilogram per day. If we substitute Q in mld, chlorine dose in milligram per liter, then you will get answer in which unit system? Kilogram per day. Therefore, chlorine dose added to water is 8 by Q. So Q should be in million liters per day. Understood? So let us work out Q value in million liters per day. Then it becomes so simple and easy. So but Q is given as 20,000 meter cube per day. So how many liters? 20,000 into liters per day. How to convert liters per day into million liters? 1 by 10 power 6 million liters per day. So it is 20 million liters. 20 or 2 or 10 power 6, 10 power 6, 20 ml. Okay. Therefore, so 20 into chlorine dose is equal to, it is 8. This is in mld, this is in milligram per liter. So we got answer in kilogram per day. Therefore, chlorine dose required is equal to, it is 8 by 20 milligram per liter. 8 by 20, how much it is? 0.25 or 4 by 10. 0.4. 0.4 means 4 by 10, 0.4. 8 by 20 means 0.4, I think. Yeah, it is 0.4 milligram per liter. That is the answer for first question. Then chlorine demand. How to find out chlorine demand? Chlorine demand is equal to chlorine dose minus residual chlorine. Chlorine dose is given as 0.44. Residual chlorine is given here 0.15 minus 0.15. So chlorine demand is 0.25 milligram per liter. See now, indirectly all information is there in the hidden in the question. Understood? That's how we can work out chlorine demand questions. Okay. Next. Forms of chlorine. Chlorine could be added to water in any form. Forms of chlorine. Chlorine is added to water in any one of the following forms. One is, it is added to water in the form of bleaching powder. We also call it as calcium hypochlorite. Or it is added in the form of chloramines. Or it is added in the form of chlorine gas. Or it is added in the form of chlorine dioxide. But at present, chlorine gas is most popular method of adding chlorine to water. Earlier, bleaching powder, now it is chlorine gas. So everything has got its own advantages and disadvantages. Bleaching powder is economical, but bleaching powder has got smell problem, taste problem. It is also known as calcium hypochlorite. CaOCl minus calcium hypochlorite. Shortcut to write it as bleaching powder BP. So bleaching powder impart odorant, bleaching powder cause odorant taste problems. Though it is economical, cheapest chemical, but not being used widely at present because of obvious reasons. Bleaching powder, chlorination with bleaching powder is economical, but bleaching powder cause smell problem and taste problem. Chlorination of water with bleaching powder, we call it as BP, is economical because cheap method, but bleaching powder cause odorant taste problems. So So because of that, so we don't recommend. So whenever we add bleaching powder contains only 30 to 35% chlorine. Bleaching powder contains only 30% to 35% of chlorine. So whenever they ask questions related to bleaching powder, what is that bleaching powder dose to be added? Bleaching powder dose required to be added is equal to, that depends on chlorine dose by available chlorine in bleaching powder. So from this you can calculate. This kind of questions also very popular. Finding the bleaching powder dose. If you know the chlorine dose, you can find bleaching powder dose. If you know bleaching powder dose, you can find out indirectly how much amount of chlorine dose added to water. Okay. Such type of questions also they are asking in exam. For example, let us try one question. See, numericals only we are working out. 600 kilograms of bleaching powder is consumed per month to treat 10 mld water to have a chlorine residual of 0.2 milligram per liter containing 35% of chlorine. Find chlorine demand of water. They ask like this. Come on, how to work out chlorine demand of water? Chlorine demand is equal to chlorine dose minus residual chlorine. Residual chlorine is given 0.2. Chlorine dose is not given, but bleaching powder is given. So from there you can work out. Come on, work out, try. Yeah, already solved numericals and biological pyramid ambient test. Numericals are solved in the last class. See that biological water quality one. They have this, that is telecasted in heat transfer some other platform. I think biological water quality. Okay. Find out that. So per month 600, per day how much it is? Can you work out per day? Total bleaching powder consumed per month is equal to 600 kg. Therefore total bleaching powder consumed per day is equal to 600 by 30. So it is 20 kg. So total bleaching powder consumed is equal to Q into bleaching powder dose, which is equal to 20 kilograms per day. So substitute Q in mld, this in milligram per liter, will get that one. Therefore bleaching powder dose added indirectly to water is 20 by Q. So 20 by 10. So it is 2 milligram per liter. Q is given 10 mld, isn't it? Okay? Q is given 10 mld, no? 2 milligram per liter. But on 2 milligram per liter of chlorine dose is equivalent to how many milligrams of bleaching powder? Bleaching chlorine dose is equal to, it is bleaching powder dose into available chlorine in bleaching powder. So 2 milligrams, but it contains only 35% of chlorine. So it is 0.7 milligram per, indirectly it is 0.7 milligram per liter. Therefore chlorine demand is equal to, it is chlorine dose minus residual chlorine. So 0.7 minus 0.2, it is 0.5 milligram per liter. That was the answer for this question. See now, so much information is not there, but yet we arrived at a correct answer. Clear now? Alok Pandey, only one person taking class now. You also left Alok Pandey. So that is how we can work out problems related to bleaching powder. Similarly, chloramine is also there. Let us try one more question on bleaching powder. So one more question on bleaching powder. Let us try one more question. Example 7. It is required to supply water to a population $20,000 and per capita demand $150 LPCD. Determine how much bleaching powder. I wrote it as BP. BP stands for bleaching powder. Is required in kg, required in kilograms, and average per day. If chlorine dosage is 0.2 ppm, bleaching powder contains 30% of chlorine. Come on, work out this question. Similar lines like last question only. on. So what you have to work out? Extra thing here, Q you have to work out. So Q is equal to what? Population into per capita water demand. Population is given as 20,000. Per capita water demand is 150. This also liters per day. If you convert into million liters per day, multiply by 10 power 6 mld. Straight away will get mld. 3 mld it is. Okay. Then what else is given? Chlorine dose is given. Can't you work out bleaching powder dose? So bleaching powder dose required is equal to, it is chlorine dose required by available chlorine in bleaching powder. So chlorine dose required is 0.2 ppm. 0.2 ppm means 0.2 milligram per liter. Available chlorine in bleaching powder is 30%. So it is 30 by 100. So bleaching powder dose required is 0.667 ppm or milligram per liter. Therefore total bleaching powder required per day is asking that only. How much bleaching powder required in kilogram per day? So total bleaching powder required per day is equal to, this Q into bleaching powder dose. So 3 mld into 0.667. So mld into milligram per liter straight away will give answer in kilogram per day. So it is 2 kilogram per day. That was the answer for this question. Understood? So we can work out problems related to bleaching powder just like this. They are very popular. Second, chloramines. Chloramines takes its own time in destroying the organisms, not as popular as chlorine gas. Takes chlorine react with ammonia and produce chloramines. So chlorine react with ammonia and produce chloramines. First it produces monochloramine, dichloramine and trichloramines are produced. So chlorine in the form of chloramines are known as combined chlorine. Are known as combined chlorine or combinedly available chlorine. So whenever you come across with term combined chlorine, by default it is chloramines or combinedly available chlorine. Okay, that way also you can say. Free chlorine means chlorine in the form of HOCl and OCl. Chloramines means combinedly available chlorine. They are in the form of monochloramine, dichloramine or trichloramine. Mono and di are more powerful than tri. Therefore, we maintain mono and di in water. So chloramines produce long and persistent residuals which give long protection. So you want to get long protection, you should have chloramines as a residuals. Okay, that's an important point. So chloramines takes a little more time when compared to other forms of chlorine. Chloramines takes more time compared to other forms of chlorine. That's only negative point. Rest of them are all positive. There is no odor problem, taste problem with chloramines, any amount you can have. No toxicity problem, etc. So you can think of chloramines also. Other forms of chlorine. Next one, chlorine gas. At present, chlorine is used in the form of chlorine gas only. Chlorine gas 2.5 times heavier than air. Quickly dissolve in water and produce free chlorine in water. Quickly dissolve in water and produce free chlorine. That's why very popular. This can be stored, chlorine gas can be converted into liquid chlorine, and liquid chlorine converted into gaseous chlorine by applying pressure, by removing pressure. So pressure if you apply, it is converted into liquid chlorine. Remove pressure, apply pressure, remove pressure, then again liquid chlorine converted into chlorine gas. Therefore usually it is added in the gaseous form, and storage and shipping, transport is carried out in liquid form in containers. Added to water in gaseous form, and storage and shipping, storage and transport in containers in liquid form. So comfortably you can carry out the job. So that's why very popular. But high amount of, if free chlorine react with organic substances anywhere, it produces trihalomethanes in water. Those trihalomethanes are carcinogenic and cause cancer. So therefore carefully we need to apply. So if free chlorine react with organic substances, produce THMs in water. THMs means trihalomethanes in water. So THMs are carcinogenic in nature. This kind of risk is not there with chloramines and cause cancer. Therefore carefully we need to add. So if free chlorine residual is greater than 0.2 milligram per liter, then there is a high risk of THM. If a free chlorine residual is, so chlorine gas is adjusted in such a way that less than 0.5 1 milligram per liter, no future protection. So we supposed to have future protection, there is a low risk of THM. Therefore, that free chlorine residuals maintained in water. Therefore, as per IS code, free chlorine residual in water should be anywhere between 0.1 to 0.2 milligram per liter. Should not be less than 0.1, should not be more than 0.2 if chlorine gas is used. That is the point. Okay. So low risk of THM, low risk and future protection, both you will get. Still risk is there, but very low risk. Both will get for this free chlorine residuals. Understood? You can't say that zero risk. Still low risk is there, but at the same time we also get future protection if you maintain free chlorine residuals anywhere between 0.1 to 0.2 milligram per liter as per IS code. So you need to adjust your chlorine dose in such a way that, so see that free chlorine residual is not more than 0.2, not less than 0.1. Okay, that's all. Then chlorine gas is chlorine dioxide, right? Chlorine dioxide. Chlorine dioxide also, like ozone, it is unstable, which cannot be stored. Therefore, it is ruled out. Chlorine dioxide. So it is unstable. Therefore, cannot be stored. Generated just before use. Okay, before use you have to generate. Expensive method, expensive among all forms of chlorine. So therefore it is not been used popularly. Chlorine gas is very popular. So this is about different forms of chlorine. Then still so much is there. We'll continue our class at 2 o'clock. So today I'll take a class from 2 p.m. to 4 p.m. Here remaining portion of disinfection I will cover along with miscellaneous water treatment. Miscellaneous water treatment methods. Today. And again 8 p.m. to 10 p.m. I'll talk about distribution system. Water distribution system. And we'll finish up the water supply engineering with this. So today I'll take 2 more sessions. One is from 2 p.m. to 4 p.m. The another session is from 8 p.m. to 10 p.m. Okay. Do notice these 2 timings. Do attend the classes and follow me and maximize your score in exam. 100% I'm sure that if you follow all these questions, then no problem for you in answering the questions in GATE exam. 100% I can assure you. That much confidence I can give it to you. Trihalomethanes. THM stands for trihalomethanes. Trihalomethanes such as chloroform, bromoform. You might have seen, no, people kidnap using chloroform. Chloroform smell if you show to any person, he will be sedative. He will get into coma state. Smell only that much. You can drink water containing chloroform, bromoform, etc. Then what happens? Imagine what happens. So will be no more in this world. Understood? Alok Pandey. THM stands for trihalomethanes. Kidnaps. How we carry out kidnap? Chloroform. Smell if you show chloroform smell like this, finish. Kidnap happens. So today 2 to 4 again, I'll try to cover remaining portion of disinfection and as well as miscellaneous water treatment methods. Remaining treatment methods. Okay. And 8 to 10 water distribution. Then we'll wind up today water supply engineering. And tomorrow we'll start wastewater engineering. Tomorrow, day after tomorrow. And 4-5 days I'll complete your syllabus. I thought of completing by 25th before Christmas. But anyway, because of technical issues, I lost so many sessions. Okay. Then last but not the least, this is the promotional content. Some mock examinations they are conducting in Enroll, taking a core GATE Civil. Okay. So many modules are available. You can subscribe. So thank you very much. But do attend afternoon session 2 to 4 and as well as 8 to 10. So 2 more sessions I'm planning to take today. I'll take and I'll complete water supply engineering. Thank you. So today again I'll be taking class 2 p.m. to 4 p.m. and again 8 p.m. to 10 p.m. Today's schedule 2 more sessions. One is afternoon 2 p.m. to 4 p.m. The another one is 8 p.m. to 10 p.m. Okay then. Bye bye. We'll meet again in the afternoon, sharp 2 o'clock.